Hello, future engineers, subscribers, viewers, and students. Here is another lecture video in plane trigonometry. I hope that through this video, your knowledge in trigonometry will be added and enhanced, especially the preliminaries and in the important concepts. So this is about sum of interior angles of closed polygons. Triangle is one of them, and names of angles so that you can solve uh, problems associated with the particular name of angles and some other terminologies. So let's have the principles and formulas first. So if this is a triangle, then this is the measure of this vertex angle, angle A. By the way, angle A may be called angle BAC or CAB, but we simply call it angle A. Angle B, on the other hand, may be angle CBA or ABC. So the middle letter should be that angle, while angle C may be called angle ACB or BCA. But we simply call these interior angles of a triangle as angles A, B, C, and in particular we call them vertex angles. So let us show here that the sum of the interior angles of a triangle is 180 degrees or straight line angle. So first let's extend AB as shown, and we draw a line parallel to AC. So let's draw a line parallel to AC through vertex B as shown. So since this line is parallel to AC, and this line is simply the extension of AB. Therefore, if this is angle A, then that angle, which is the angle between this side, which is parallel to that, they are parallel, and the extension of AB. So the measure of this angle is also angle A, as shown. Then, since this is parallel to AC and this is the common side BC, this angle is denoted angle C, the angle between the horizontal and this side BC here. And since this is not necessarily horizontal, but the angle between side AC and BC, and since this line here is parallel to side AC, and we also have BC, so no doubt this angle is equal to the measure of C. So that is angle C. Then finally, this is vertex angle B, so that's angle B. Notice that angles, the sum of angles A, B, and C is a straight angle, and a straight angle is 180 degrees. So the sum of the interior angles of a triangle, therefore, is 180 degrees. And as a student in trigonometry or in engineering, you must know that. Then how about for closed polygons of any sides or any number of corners? So we use this concept, in order to derive the formula for the sum of the interior angles of a closed polygon. So I have here a representative polygon which is a pentagon, but you can also have a quadrilateral, four sides. So if there are four sides, we draw lines AC, diagonals AC. We draw line AD. So if there are only four corners, A, B, C, D, or or four sides, then we can draw non-overlapping triangles. We can only draw two non-overlapping triangles, right? So we cannot introduce triangle ABD anymore because it overlaps with the first two triangles. Likewise, if we delete this division, then we can have BD as the division, but there are still two non-overlapping triangles if there are only 4 corners or 4 sides. Now, if there are 5 corners, 5 points, then we can have 3 non-overlapping triangles. So if it is 3-sided, a triangle, there's only one triangle, non-overlapping triangle. If there are 4 corners or 4 sides, there will be 2 non-overlapping triangles. And if there are 5 uh, 5 corners or 5 sides, then we can draw 3 non-overlapping triangles. If there are 6, then we can draw 4 non-overlapping triangles. So in that pattern. So again, 4 corners or 4 sides, we can draw 2 non-overlapping triangles. 5 corners or 5 sides, 3 non-overlapping triangles, if you look at the figure. And 6 corners or 6 sides, we can draw 4 non-overlapping triangles. Therefore, in general, if there are n corners or n sides, we can draw, in general, n minus 2 non-overlapping triangles. So to check, if there are 4 sides, 4 minus 2, 2 non-overlapping triangles. If there are 5 sides, 5 minus 2, 3 non-overlapping triangles. If there are 6 corners or 6 sides, 6 minus 2, 4 non-overlapping triangles. So this is correct. Therefore, because the sum of the interior angles of each triangle is 180 degrees, the sum of the interior angles of a closed polygon with n corners or n sides is number of non-overlapping triangles times the sum of the interior angles of a triangle, which is 180 degrees. The formula, therefore, for the sum of interior angles of a closed polygon, is quantity n minus 2 times 180 degrees. So summation of interior angles of a closed polygon, quantity n minus 2 times 180 degrees. So to illustrate this, if for pentagons, then we have 5 minus 2 times 180 degrees, that's 540 degrees. For nonagon, quantity 9 minus 2 times 180 degrees, so that's 1260 degrees. So for some other terms, so let's have central angle or central angles. In this case, we denote central angles as alpha, beta, and gamma in the figure shown because that's the angle between two radii of a circle with vertex at the center of the circle, which is shown here. So this is the center denoted with O. So the central angles are alpha, beta, and gamma. So alpha, beta, and gamma are called central angles. So these are the sides. For alpha, for example, R and R, and this is the central angle. For beta, sides are R and R, and the central angle is beta. And finally, for the third triangle, gamma, central angle, sides are R and R. Then, A, B, and C are called specifically as peripheral or inscribed angles, and there's relationship between inscribed angles and alpha, and that relationship will be established later so that we can derive many formulas involving triangles and circles. So as of the moment, let's accept the fact that triangles ABO, BCO, and ACO are equilateral, are isosceles triangles because uh, two sides are equal. So therefore, opposite to these equal sides are also equal. So alpha also is twice of angle A, beta is twice of angle B, and gamma is twice of angle C. So the proof of this will be deferred until we reach an important concept, properties of circles and triangles. I will prove that, and That's why for the law of sines, the ratio of any side to sine of the angle opposite it. So this is side B as to sine of angle B equals side C as to sine angle C is constant, equal to 2 times the radius of the circumscribing circle, because we can always circumscribe a circle about a triangle, or we can always inscribe a triangle in a circle. That's the other way. So for the moment, you just accept that fact and make it part of your knowledge. So triangles ABO, BCO, and ACO are isosceles. Then we define inscribed angle as the angle between two chords of a circle, or simply the angle between two sides of a triangle. So angles A, B, and C are called inscribed or peripheral angles. So take note that points A, B, and C are on the circle, on the periphery of the circle. So, so let's now have types of angles. Let's have the name and the measurement and the illustration. So for first one, we have the null angle. The measurement is 0 degree, theta is 0 degree. And for the illustration, we have the initial side, which is that dashed line, lines ray or line segment, and the solid line is the terminal side. So that's why we have 0 degree. Acute angle is between 0 and 90 degrees. So 0 degree is less than theta, and theta is less than 90 degrees. So for the illustration, that's the acute angle. So example, 42 degrees, 34 degrees. Right angle, when the angle between the initial and the terminal side forms 90 degrees as shown in the figure. So that's right angle. Obtuse angle is when 90 degrees is less than theta and theta is less than 180 degrees. So that's the illustration for an obtuse angle. Example, 135 degrees, 155 degrees, 100 degrees. So between 90 and 180 degrees. Then greater than this but less than one full angle is the reflex angle. Straight angle next. When the measurement is exactly 180 degrees, just like the sum of the interior angles of a triangle. So 180 degrees, so it's just a straight line. That's the initial, the terminal should be on the other side. And that's 180 degrees. Then we have the reflex angle. The angle measurement is between 180 degrees and 360 degrees. So that's the initial, that's the terminal, and that's the angle theta. Then full angle or perigon, when the measurement theta is exactly 360 degrees. So the illustration would be like this, but the solid line should be below. So that's the initial line, and that's the terminal line or terminal ray or side, and that's 360 degrees. We call that full angle or perigon. Then when the sum of two angles theta 1, theta 2 is equal to 90 degrees, we call each of them as the complement of the other, or they are called complementary angles. When the sum is equal to 180 degrees, then each of them is called the supplement of the other, or we call these angles supplementary angles. And finally, when the sum is equal to 360 degrees, then we call each of them as the explement of the other, and these angles are called explementary angles. So that's it for this video. I hope that your knowledge in trigonometry is increased little by little, And I hope that you can retain these concepts as we move on.